Start my session tonight with a story, and I want to talk to you a bit about a wedding that I went to 5 years ago. When I was at that wedding, I had an experience which I think informs the rest of what I'm going to talk to you about this evening in this session. As happens at many weddings, I ended up at a table on the reception with all the IT guys, with all those people that work in the same sort of industry that have some form of shared interest, even if they don't necessarily know each other. But I did know one person on the table that I was with, and it was an ex-manager who'd moved on to another business where he was in control of a software delivery team that was building applications for internal users of that business. And we talked about a range of different things, like you do at any wedding, but one of the things we kind of veered onto because of the table I was on was the quality of software solutions that people were delivering and how hard it was to do this on budget, on time, and with the flexibility we expected for these solutions to have longevity in the organisations that we worked in. And what he said to me next almost knocked me off my seat. He actually said, I don't care about the underlying quality of the solutions that get built by the team that I run. All I care about is the fact that they go to the users are more efficient in the jobs that they do, and that the users are happy. Now, I was absolutely flabbergasted by this, and I didn't really realise it at the time, but it obviously had a big influence on me because I'm talking to you about it today. But ultimately, at the core, what I found, objectionable about that statement was that here's somebody who works in the same industry as me, who doesn't have the same passion about software craftsmanship as I do, and is prepared to admit to it and to talk about it in that way. The reason I bring this up is that maybe today I'll say some things that will make you all feel that way about me. Is that I'm standing up here and I'm being the guy that's telling you that the thing that's important to you is actually maybe not that important anymore, and it's time to go away and look at other things. But I have to say that in some respects he was right. And in the preceding time since I went to that wedding, and having spent a lot of that time working in the cloud space, what I've come to see is that it's not only your users and your customers out there that are using the solutions that you're delivering for them that have that expectation that it just works without knowing the underlying technology that you've used to implement it or how good your engineering processes are. It's now come down the chain. Developers in your development teams now demand to have environments at the push of a button that they self-manage, as we always have, I guess, because I'm a software developer, but now they have a higher expectation of that because the cloud has enabled those scenarios to be a possibility. And IT pros aren't left out of this either. IT pros now look at what goes on in the cloud environment where the latest version of Windows Server or the most recent Linux distribution drops, where software-defined networking is occurring, or they have access to the latest tools to allow them to do their jobs. And they no longer want to wait 3 to 5 years for the next refresh cycle before they get their hands on the latest and greatest technology to allow them to do their jobs better. Which brings me to Microsoft's current mission statement. And I think that this mission statement, as broad as it is, talks to the heart of the transformation that's happening with cloud technology in our industry at the moment. It's about releasing the constraints that we've always had to work with, whether it's from a technology infrastructure standpoint or from an individual standpoint, about not having access to enough resources to do things the way we would actually like to do them. Like any mission statement, it's broad. So what I want to do is I want to try and frame it down to cover this one session that I'm going to go through this evening and look at it like this. So this session is all about how you, as practitioners in our industry, can leverage cloud technology to change the way that you work, to deliver better outcomes for the people that you work with, either as an individual or as a business, as a team. We're going to spend some time knocking down walls and then thinking outside the box, and then, as a reflection of the title of this session, we're going to topple ivory towers. And we're going to look at how we can modernise the way that we work when we're delivering solutions. And we're going to look at how Azure can help us improve the chances of boosting the ROI in the solutions that we deliver while we're bringing down the risk at the same time. So how do we rebuild from this? Today we're going to do a few simple things. First of all, we're going to look at some of the mistakes and issues that we have, maybe in our current environment or that we've had in the past. Identify them, call them out, so that we know that we're not going to make them again if we see them, even when we move into a cloud environment. Then I'm going to talk about a few of the fundamentals at a very high level of what we need to take into consideration when we're designing and delivering solutions that are built as cloud native. And then finally, we're going to have a look at specifically how we can use Azure features to boost the ROI of solutions that we deliver while at the same time reducing risk. Does that sound like a plan? Does that get you happy? Are you happy to be here eating dinner at 6:30 listening to this? Yeah. Oh, come on, yeah. All right. So first section we're going to cover is just a very high level, quick section on things that we might see, may be able to identify in our current way of working, and then we'll look at how we address those by moving into a cloud environment. So these are what I've broadly classified as design challenges. These are early stage challenges we see when we design and deliver solutions. I've kind of phrased these in fairly high level terms, but I'm sure if you reflect on your careers, maybe not in a job you're in now, maybe in a previous role, some of these would seem familiar to you. So the first one, which is having to build designs or create designs based on some constraint, whether it's a monetary constraint or an infrastructure constraint or some other constraint that's placed upon you when you're designing a solution. What that results in is it results in a lot of additional effort as you have to iterate over solutions that fit within the constraints that you have, which obviously means that in some instances you end up with a suboptimal outcome because you design the best possible solution based on the constraints that you have, but you burn a lot of time to get there. Not great. The next one is kind of the inverse of that. You're only going to get one bite of the cherry to deliver this solution or a group of solutions, so you over-engineer. You over-specify the infrastructure you need, you over-specify the software that you might need, or you budget more for the operational component of this solution than you might otherwise have. And I'm sure we can all think of those times where we've been sitting down to specify either some hardware or some software, and we've adjusted those numbers upwards, either through wanting to deal with the unknowns around capacity that we might have to deal with if this thing actually flies, or because there's some parallel piece of work that's going on that might want to make use of this but doesn't necessarily want to go through the whole process of getting budgetary approval for that money. Okay, we've all been through that. This third one, which is designing for peaks that only occur occasionally, I'm sure you're probably sick to death of hearing that in the cloud space because that's kind of the classic where it all started model. The Christmas peak that a certain online bookseller was having to deal with meant that they had to buy all this kit that was pretty much idle for most of the year. So what did? They turned it into a resource that they could go out and rent to people. But that really is, if you're trying to do that in a non-cloud environment, that's a hard one to solve. Invariably, you'll end up spending more money and having more resources on hand than you otherwise need. And then the bottom one, maybe a bit of an esoteric one, but doing proper disaster recovery. So we've all designed those. Here's what my primary environment looks like, and here's what my secondary environment looks like, and then have someone come through with a big red pen and cross out the bits that they can't afford to put in the secondary environment, or to run in an active-active configuration. And the result is that, sure, you end up with a DR environment, but how much confidence do you have in it that when you actually have a disaster event and you need to fail over to it, that you're either going to be within some a pre-agreed SLA, or that you're going to be able to resume service or have all the services available without having to work around constraints because you know that some things don't exist there. The next one is infrastructure, and I realised after I put this session together that maybe it feels a little bit like it's ragging on the infrastructure guys in the room, and that's not the case. But a lot of the constraints we see in the traditional world are tied to physical infrastructure. This one is more around infrastructure and also software. So I've been on projects during my career where you'll have to fight to get access to virtual machines in the data center, either for a test environment or a development environment or some other form of environment. Then you'll also have to fight for software licenses. Quite often there's these highly expensive bits of software that are passed around between projects like a talisman. And I can think of one particular instance where some OCR software that was used very heavily in an organization was basically if you had that, you were the blessed project. Now you can imagine the impact that has on being able to deliver efficiently when you know that, well, I've got a reliance on that piece of software. I have to wait for it, or I have to justify the cost of buying additional licenses for it. So this leads me to my next point, which is kind of related to this one fairly heavily, which is having to work your way through a constrained number of environments or shared resources that are outside of your environments. This doesn't raise its head very much in production environments, but it has a very big impact on non-production environments, whether it's performance test environments, user acceptance testing environments, integration testing environments. The big impact that we have here is because so much time and energy goes into building test environments or non-production environments, they end up being treated like production environments, which means that any faults or failures in those environments are investigated, and they're investigated probably beyond the realms of what's absolutely necessary given the fact that they're actually not production environments. Returning those environments to a fresh state for the next user, the lead time for that can sometimes be quite substantial because the volume of data it takes to restore and all the virtual machines you need to reset, because you've got precisely one or two of those environments, it suddenly becomes a very big management overhead. And what about when you've got a very fast-paced business that's doing a lot of innovation and iteration using an agile delivery methodology? Now, a lot of these problems stem from a traditional waterfall method where we push a lot of testing towards the back of our delivery, but agile doesn't get away with, being scot-free here either. In fact, it probably amplifies a lot of issues because you've now got a large number of small projects trying to move through still a restricted number of environments, and they're much more susceptible to delays in delivery because they're working on 2-week, 1-week, 3-week, a month-long iterations where they need to prove that they've got functional software at the end of it. And if they can't have a development environment for a week, say, for instance, it has a much broader impact than a large program of work in a waterfall sense that might be 6 months. A week is a much smaller impact for them. I'll wrap this section up by asking an open question. So what do you think, with those issues we've just talked about, the impact is going to be on the return on investment for the solutions that you're pushing through those sorts of environments? It's going to be a pretty impactful outcome for those projects. And what about, not the first person to do that. What about risk? You think about the risk involved with this. If you're not sure you're going to get through testing in enough time, risk is going to go up. If you're not sure you've got the right infrastructure in place to be able to deliver a solution, risk goes up. If you ask for a big budget because you want to over-engineer your solution, your risk goes up. And a lot of the risk that's tied to IT projects is usually because of constrained resources, whether it's people or infrastructure. So if we can have a positive impact on that constraint, we can help reduce the risk. That's what happens if you don't deal with those. The whole thing comes tumbling down. So let's talk about some new foundations. And this section I'm just going to talk briefly at a very high level about some design fundamentals we need to take into consideration when we build cloud native solutions or when we're looking to re-platform to the cloud. So let's have a look at those. Hopefully none of these are news to you, but if they are, great. Hopefully you'll get something out of this slide. But scale, state, resilience, and data consistency are kind of the four main areas I would see when you're moving to a cloud environment you need to take into consideration in any architectures you pull together. Scale. Traditionally in your own data center, scale would usually be a matter of scaling up. So putting more RAM, more CPU, more disk into individual instances. And then maybe if you need to have a couple of those instances and maybe load balance them, great, fantastic. You can still follow that model in the cloud if you like, but you're not going to get the benefits of moving to a cloud environment if you're still using scale up as your way to deal with load. You want to scale out. So instead of having a small number of large instances, you have a large number of small instances. You still load balance them, but obviously you need to take that into consideration when you put together your architecture to take that into account. That may not work for you. Again, that's an input into a decision on where this thing is going to live when you build it. If you're scaling out, immediately you start to see the impact that that has on state. If you have a lot of state tied into those individual instances and it's held locally within the instance, if you scale out, you then have to think about how do I deal with a consistent user experience across all of those instances that I have running in this environment. Typically you would do that by removing as much state from those individual scale units as you can and pushing it to some form of out-of-process state management system like Redis cache or SQL database or some other mechanism, those scale units should be effectively stateless. They should be able to fail, and something else should be able to come up and take on the work that scale unit was doing. If you can't achieve that, that's something else you need to be able to deal with. And that leads on to resilience. So the way we build resilience in our data center generally tends to be at the instance level. We put lots of redundant power into our machines. We put lots of redundant disks into our SAN. We have redundant networks in our networking environment. In the cloud, the way we do resilience is different. There are still lots of resilient things in there. You don't see them. They are obfuscated away from you by the fabric of the cloud environment. But you need to deal with the resilience in a different way. So instead of having multiple interface cards, multiple power supplies, you now have multiple instances where we come back to that scale challenge. Is you want to be able to have multiple instances so that in the event that one fails, something else will pick up that load and run with it. Now, availability sets and those sorts of things in Azure will help you design for resilience, and then doing cross-region resilience with things like Traffic Manager can help. But clearly that's not going to suit every scenario. But we need to think about how we do resilience when we move to this environment, because it is different. And then the last one is data consistency. If we start talking about geo-redundant services, Sydney, Melbourne, for instance, and we want to have data consistent in both those locations, probably not going to work, just because of the sheer effort to keep the data in synchronization between those two physical locations. Even at the speed of light, that's still a lot of information to push from one location to another, which means we need to think about the consistency model we want to have for our data. At one end, we have very strong consistency, which is a traditional model that we have today in most places, which is when I write some data to something, when I read something back, I get that read back straight away with my write. That's a very strongly consistent model. That doesn't work at scale with a geo-redundant data store. What you need to move towards is the idea of eventual consistency, is that my write will eventually be read by all the nodes in the environment. And it's right to laugh because you go, well, that doesn't work for my scenario. And it doesn't work for every scenario, but there are ways, again, to deal with that. Is that the user, as long as the user experience is maybe consistent at the node, so I use a thing called like bounded staleness, where I know that the node that did the write will see the data with the read, and that the other nodes will eventually see the read, and that's okay because my application can cope with it. But I need to take those into consideration as well when I'm designing this. So that's just a very high-level overview of kind of the four main areas I think you need to take into account when you're building for the cloud. So now we've done that, let's go ahead and look at how Azure can help us with our return on investment for the solutions we build and help pull down the risk at the same time. So when I talk about return on investment, I'm going to talk about it at a very basic level. It's going to be the positive or negative, hopefully the positive, between the cost to actually build the solution and the revenue that I realise from running it. Okay, so that's the very basic way I'm going to measure ROI here. For this session, I'm going to concentrate on 4 areas of how we can manage ROI. There are a lot of others that are intangible, so things like customer satisfaction and those sorts of things, but hopefully you'll see if we concentrate on the 4 areas I'm going to cover, we hopefully lead to a better outcome for our users and our customers, and therefore hopefully it's a virtuous circle where we'll see improvements through increased revenue. So the first one is productivity. In the cloud, we can definitely do more with less, whether it's less physical infrastructure, dare I say it, with less people, with less effort even, because I can do things that I didn't have available to me in my traditional data center world that are now available to me, like APIs that I can program against or templates that I can use. I'm going to go into each of these in a bit more detail, so don't worry about that if you're not following at the moment. Next one is velocity, getting to done faster. Okay, a big problem we have with large software delivery programs of work or large programs of work is they take a long time to complete, and they don't have consistent milestones on a regular basis, which means, guess what? People get a surprise at the end when it wasn't quite what they were expecting. Now, if we can get to a point where we're delivering a lot more rapidly and we're giving people visibility over what we're doing for them quicker, then we hopefully have less of those issues. in the longer term. Next one is innovation, and I think this is a very big area that is undersold in the cloud environment. I think it's starting to increase, but people have focused a lot in the cloud space on how does it reduce my costs. Actually, it's, well, what is the innovation capability it provides my organisation with? You can now try things in any cloud environment, particularly in Azure, that you could never have even imagined even 5 years ago. Hopefully you've been to other sessions here over the last 2 days and you've seen things like cognitive services. You would have seen the demonstration that Scott Guthrie did during the keynote, where he was pulling tweets out of a tweet stream and doing some cognitive services analytics over the top of it and posting it into a team site. Now, a very basic demonstration, but you think about the individual components of that, you couldn't have done that 3 years ago, 5 years ago, and now you can. So the art of the possible is changing, and if you're adopting this, that's open to you to use. And then quality. And this one might maybe raises a smile on your face. You think quality, it's a commoditized platform. How can it be quality if it's got instances that can fail at any moment? And, you know, I have guaranteed availability but not guaranteed performance. Well, the reality is that you can actually build a better quality solution in these environments than you probably can in your traditional data center or in your traditional environment or a traditional hosting environment. So that's kind of the four levels. So let's dig into each of these in a bit more detail, and we'll talk about how Azure generally helps and then specific examples of how Azure can help with each of these. So doing more with less. So capacity management has always been a challenge, and I touched on that in the kind of issues section earlier. Now it's no longer your issue. We don't see many instances in any cloud provider and in Azure at the moment where there is not enough capacity to service customer demand. I haven't, in the last 3 years, ever had an instance where I've been told I can't provision something in Azure because there are not enough instances available. I've had it prior to that in other cloud vendors' environments where you'll click on a button and it'll go, sorry, I'm out of cores or whatever. Azure doesn't have that ability. Now, they do put some soft limits around accounts to stop you from, you know, provisioning the world inside of an Azure region, but the reality is for most enterprises, those levels are so much higher than for us mere mortals that you're not going to run into those capacity issues. And a big part of what Microsoft does in Azure, and hopefully you've seen this, is they even have economists on the team that are sitting down and looking at the run rate that they're burning through when they're doing things in Azure, so they can plan to make sure they have enough capacity ahead of the curve. I don't know how many new machines they drop into a data center in a day, but they certainly at a rate that exceeds the demand that's being placed upon them. And then they're doing clever things behind the scenes to make sure that they've got enough reserve capacity in the event that, you know, that they do actually have a burst in demand that they weren't expecting. PAYG. Now, I know for many enterprises, PAYG kind of goes along with having some form of enterprise enrollment, so it's not 100% PAYG, but the reality is that you still only draw down on that money when you're using it. Okay, so you no longer have this need to go out and provision all of this stuff and then just leave it sitting unused. When you're not using it, turn it off. Don't pay for it. No longer your issue at the point that you turn it off and Microsoft has invested that money in building the data center, not your issue. Evergreen environments, and this kind of harks back to that IT Pro statement I made at the start of the session, is that you're always getting the latest and greatest in these environments. If you think about your own environments, it's very hard to do that. You might get small amounts of new stuff on a regular basis, but in terms of having the latest and greatest of everything, that's not really a reality for most of us. And I see this one as a big attractor for many organisations when they move into these environments, because they can revisit things on a regular basis and go, well, you know what, that compute style over there I was using, actually there's a new one of those that's got a slightly different profile. The cost's a little bit more, but it probably will be better performing with my solution. Or for instance, you know, the ability to leverage the field programmable gate arrays that Microsoft dropped in to boost network performance up to 25 gigs. You didn't have to do anything for that, it just happened. You think about doing a network upgrade in your own environment, the amount of work that's involved with that, that's a lot of effort that you no longer have to worry about. And then cloud scale versus, or cloud hyperscale versus your scale. Could you put 38 regions around the world with unlimited compute and storage? Probably not. There's probably not many people in Australia or anywhere in the world that can have that sort of reach. So again, a very big booster to being able to do more with less. You no longer have to worry about provisioning this. So specifically with Azure, we now have so many different specialized compute instances, I never managed to keep up with all of them. Now we have H series for high performance compute, N series for GPU-based compute, which is really good for machine learning type scenarios. You've got the G series, which is like these massive big beasts of machines with like 48 cores and half a terabyte of memory. And then you've got the SAP large HANA instances that they've now got. So I think that was talked about in the Rio Tinto in the keynote, and how they moved their SAP environment onto Azure. And they're using those SAP HANA instances, right? They're huge. But they're there for specific workload types, and it's growing all the time. So you think about your own environments, being able to spin up dedicated types of compute for different scenarios your business might place on you. Very hard to meet that. You'll probably have general compute, and then you might put special software onto it, but you're not going to have the underlying compute platform to actually drive that. The next one, data processing at hyperscale, and that's kind of been one of those key areas. A lot of businesses are going, I've got all this data and all these metrics, and I'd love to be able to do some form of analysis and give me insights on where my business is going. The big thing about that is having to store all that data, and then having the raw compute to actually process that data in any reasonable period of time. Again, comes back to that idea of constraints. If you're not having to design around a constraint, all of a sudden you can do a lot more. Bottomless data storage. I can go to Data Lake and I can put 100 terabytes of data into Data Lake, and it costs me $4,000 a month. Now, $4,000 sounds like a lot, but how many people in the room could store 100 terabytes of data and then decide tomorrow they're going to put another 100 terabytes of data in? Or, I don't think there's many people that can kind of hit that scale. And then attach that data store to something like Data Lake Analytics or HD Insights, and actually do the number crunching for it and produce a valid output for your business users. Backup. I kind of put this one in because it doesn't get a lot of love, and it's kind of that service that just floats along in the back, and I mean, it's only as good as the last restore, but backup at enterprise level becomes a headache, and it's become, tape libraries, tape management, all that sort of stuff goes away when you move to using cloud as a backup store. You've got the proper rotation cycles, you've got 99 years of storage, you've now got file level restore at the push of a button, and it's all encrypted. Sure, it maybe puts a big demand on your networking capability, but you compare that to having to continue to manage a tape library and all the infrastructure that goes around that. It's a much more simplistic way of doing things, and it's just busy work you no longer need to worry about. Azure Web Apps, so call out to PaaS services. People look at this and they kind of go, oh, well, I'm going to have one web app or one app service per web app. The reality is you can actually stuff in the standard and premium tiers, and even the basic tier, you can stuff a lot of individual web apps into an app service plan, and you're not paying any more because you're using up the shared disk capacity and the shared compute for that app service plan by adding the additional web apps into it. So if you're a business that, say, runs a lot of campaigns and has a lot of small campaign websites, put them all in one app service plan, and you're not paying anything more than you did when you first spun that app service plan up. It's great. And if you've done high density web hosting in a traditional environment, that would align very well with the way you've run in the past. This last point is key, I think, though, is to really recognize the benefit of this. You need to be able to automate it and make it repeatable, and we'll come to that in a minute. I borrowed this statement from the Minimalist School of Architecture because I think it really calls out to what we're trying to achieve in the cloud, is that sometimes having less choice and having less things to worry about is actually more valuable. So in this instance, it was more about the simplicity and the cleanness of the design of buildings, and I think you could say that cloud is more simplistic and cleaner in its design in terms of the way it provides computing services to us as a community of professionals. Getting to done more quickly. Hopefully everyone likes desserts. When I was putting this slide together, I was thinking, oh, I'll just roll out the old pizza as a service infographic. I'm sure everybody saw that in their LinkedIn stream, Twitter stream, Facebook stream about a year and a half ago. If not, go and Google pizza as a service and have a look. But in keeping with the theme of towers, I'm going to use this fantastic French dessert called a croquembouche. And Stefan will correct me if I mispronounce it. Thank you, that's good. So it is as complex as it looks. It's a small series of choux pastry balls filled with creme pâtissier, which is like a type of custard, and then it's all stuck together with toffee. And these things usually show up at big family events like weddings, where everybody gets served with a certain number of choux balls. Now you're probably sitting there going, what's this got to do with getting to done more quickly? So Pizza as a Service tried to show you shared responsibility between building on-prem infrastructure versus running on a platform as a service platform. I'm going to start by talking about how we might do home baking. Okay, so when you home bake one of these things, and you've got to be a professional to home bake. Let's not kid ourselves here. I couldn't go and do that. Could you go and do that? I couldn't go and do that. You've got to go and buy all the ingredients for every single thing here, all the sugar, all the flour, you name it, you've got to go and buy it. And then you've got to make these things. You've got to make all the choux pastry, you've got to make the creme pâtissier, the toffee, and then you've actually got to put it all together. Now, I'd be scared to put something like that together. Happy to eat it, but not put it together. Requires a lot of ingredients, and you've got to have a lot of tools to be able to do this as well, and a lot of knowledge. And if you're lucky, it maybe takes you about 6 hours to pull one of these together. Anyone want to take a guess what the next thing is that's missing over here? Anybody? Stop me if you just want to get on and have a beer. That's fine, I understand that. No, okay. So self-assembly. So this is cloud IaaS, because this is usually the first step many businesses have taken or will take when they move into a cloud platform. Now you're still doing some of that work, but you're not having to do as much of it. You can buy the choux pastry, don't make it. You can buy the creme pâtissier, don't make it. You still got to make the toffee because you can't really buy toffee pre-made and it's not actually that hard to make, but you still make it. And then you've still got to put it together, okay? Still got to have ingredients, still got to have utensils to do it, but if you're lucky, it takes you a fraction of the time to do it. And then the last one, and I could probably put another one over here, but I stopped at 3, is the buy it from the patisserie, which is PaaS, Platform as a Service. Don't build any of that stuff. Let someone else build it for you and pay them to build it for you. And sure, there's still some time involved in it because maybe you have to make some choices at the start of the process to figure out how you want it to be when it comes out the other end of the process, but you're not having to do all of the busy work that you were doing previously when you were putting this together. So hopefully that metaphor has worked well. It certainly made me hungry. And a croquembouche is definitely more tasty than a cloud environment for sure. So getting to done more quickly with Azure. Infrastructure as code. I love that word, infrastructure as code. I mean, I'm a developer, so infrastructure as code appeals to me greatly. Azure Resource Manager, which hopefully you're all aware of and you will have been to some of the sessions on, is really the way we drive this in Azure. Yes, we have PowerShell commandlets, we have REST APIs, we have cross-platform CLIs that allow us to programmatically interface and control Azure, but the Resource Manager templating construct is really the key way that we drive infrastructure as a code and environments as code, the ability to provide multiple things in Azure pre-configured as a template that we can redeploy anywhere. And that Azure Resource Manager template, ARM templates, drives the thing called dev test labs. So we've all been in those environments where you've got needy developers or needy testers who feel they're special and they need to have their own development environment or their own test environment that allows them to do some form of thing in isolation to others. Dev test labs is a realization of that. You can take ARM templates that you've already created and you can allow developers or testers or people who don't necessarily have high-level permission in your Azure environment to go off and provision these environments. And you can set some parameters on what they can do. You can set where they can provision these things. Don't allow them to provision them in Australia. Put them in West US where they're cheaper. Don't allow them to provision virtual machines that are above a certain size so they can't run up the costs without you knowing about it. It'll bump on the top and shut off. Put an automatic stop and start in so that they don't leave it running on the weekends. And because we can template this, we can create as many of those as we like. Whether it's for developers or testers, we solve some of those issues around having to work with shared environments. Continuous delivery. So continuous delivery using Visual Studio Team Services or GitHub as the source for the information or the data that or the solution that you want to deploy. We'll take a little bit more of a look at that one in a moment. And then finally, PaaS, the Azure PaaS platform. So this is really where Azure started. AWS came at the cloud from a pure IaaS perspective. In many ways, that's very much their sweet spot. But Azure came at it as a platform as a service offering. So if we think about how Azure was when it launched, in 2009, 2008, 2009, we had Azure SQL Database, or whatever it was called at the time. It's been through several renamings since. And then we had web worker and VM roles. And the VM role was some sort of hybrid IaaS thing and quickly disappeared and became just standalone VMs. But that's always been at the core of Microsoft's approach to Azure. And if you look at the multitude of services that are in Azure today, many of them are PaaS. The IaaS side of Azure is very strong, and it has had to become very strong to compete with others in the market. And in many ways, it's probably exceeded some of the others in the market in some of its features. But PaaS is absolutely the sweet spot, and where you can realise the boosted return on investment in the cloud, because there's a lot of underlying infrastructure work you no longer need to do when you're actually building solutions. So I did say I would talk very briefly about continuous delivery. Who in the room is a developer, out of interest? Okay, sort of, yeah, the infrastructure guys at the front that do PowerShell kind of going, yeah, maybe. That's all right, I write PowerShell too, it's okay. So Azure, this is for a web app in particular. Web apps have had the ability to do continuous deployments for a while in Azure. They've recently added a new feature which is now called, it was continuous deployment, so in this screen here it's that deployment options used to be where you configured it, and now you use this new thing called continuous delivery. The benefit of this, and I won't go long on this, the benefit of this is that when you create this, particularly when it's attached to Visual Studio Team Services, which is cloud-based TFS, it'll create what's known as a release management profile in VSTS. And release management is a feature in VSTS that allows you to do component management and deployment. So if you've heard of a product called Octopus Deploy, it's very similar to Octopus Deploy in many ways. And because now you see that in Visual Studio Team Services, you can modify that. Before in the old world, it used a webhook to tell you to go and pull some code and compile it and deploy it, and was very, very opaque to anyone that was in VSTS. Now I can actually go into VSTS and I can edit the release management profile, and I can do things like set up multiple environments, set up manual approvals to stop things being deployed to certain environments. And I can do that by clicking through a few buttons in the Azure portal and have it set up. And literally, it's if I choose not to do any tests, I can literally have this done in under 5 minutes. Assuming I have source code in VSTS I want to deploy, or GitHub I want to deploy, and I can have a consistent pipeline set up. Having done this a lot in the past in my job, this was days of work sometimes in other environments, and now I can do it in under 5 minutes. And that's a consistent theme I'm seeing this year at a lot of the talks that we're talking about at Ignite, is that these things that used to take a lot of time, once upon a time it was even just hours, now it's minutes. And the thing that's great about that is now that you're concentrating on more valuable work as IT professionals, rather than having to worry about editing text files and all those sorts of fun things that no one really enjoys unless they work with BizTalk. Oh, I thought that would get more of a laugh than it did. Never mind. There's not enough BizTalk guys in the room. They're probably off drinking beer, right? So, all right. Getting to done more quickly with Azure. I'm going to do a bit of self-promotion here. So Azure Functions, which you've probably seen talked about a lot, you no longer need to provision anything. It is literally service event-based programming. Attach it to a queue, listen to a message, do some form of programming on top of that, write a very small microservice, and then integrate with something else. Okay, Scott Guthrie's part of the demo in the keynote showed that. He was calling out to a function. This one we called a Braintree, which is a payment gateway provider out of the States. We called that and turned it into a payment gateway processor, where the messages to pay would come up a service bus queue, and every time we got a new one, we would create a new one of these these Azure functions and go off and pay it. Scales infinitely large, because these each run in parallel in their own instance space, so we don't have to worry about virtual machine scale sets, we don't have to worry about storage accounts, any of that stuff. It's just there and it just executes. And the other one is, and there's a couple of sessions coming up in the next couple of days on Azure Active Directory B2C that I recommend you go along to if you're doing anything in the consumer or community identity space. This is identity as a service, and it's identity as a service at scale. So this came out of work Microsoft did with Real Madrid, and they support, I think, 450 million users at Real Madrid. And you now have the ability to use that scale in your own applications if you want to, by going and standing up a B2C environment and using it as the source of identity information for consumers or customers for your organisation. And the great thing is once you stand it up, you can configure it to use multiple applications. So it could be some third party wants to come and provide a service to your users, to your customers, and you can grant them access to that information through B2C and then determine what user profile information they have access to. And if you don't like the way they're working with you, you can then cut off that access by deleting the application out of the B2C setup. Doesn't mean that they won't have already grabbed some of the information, but it means that you can immediately stop the ability for people to use your authentication source as a way to get into some third-party system. Very powerful. So both of these things I'm using in a production environment at the moment. B2C is not yet in Australia, but hopefully it will be in Australia in a not too distant future. Functions are definitely here, well and truly, as you've probably seen. I love this one. I don't know who said it. It was anonymous. I was told that I should put anonymous on there to make it have more meaning, but I think getting to done faster means that we stop being as caring about things that people tell us don't work well or are wrong or that we should change or that we should have done differently, because we didn't invest a lot of time and energy in deciding on it as the right thing to do. So we just said, okay, fine, well, let's look at a different way to do it and stop holding on to our egos because we think, oh, I spent so long getting this right, it's got to be right. No, we can move away from that now that we start working in this way in the cloud. Innovation. So I don't know how many of you had the joy of working with Netscape Navigator. Looking people in the room, probably a lot of you. But Mark Andreessen was one of the young college kids that came out and founded Netscape. He made a bucket of money out of that and then went off and became a venture capitalist and now sits on the board of Facebook. He was a prolific tweeter. He stopped about 6 months ago, I'm not sure why, but this is a statement that he made and I think it's absolutely so true. And I think many times, you know, as an experienced IT practitioner, we sometimes forget this capability exists. We think about what our world consists of on a day-to-day basis and we don't think outside the box. We don't make the opportunity to explore other ideas. And if I look back on, you know, my time in the industry and I think about working through the dot-com boom, how many of those dot-com businesses, those startups, went out of business because they spent so much time and money just putting in data center space, racks of servers, connecting it to the internet, paying for data, and they did all of that before they even started building the software that was going to be the solution that they wanted people to, or businesses to use. Okay, this is so true. Anybody can turn up with a credit card today with an idea and try it out. And sure, they might burn their credit card out and end up in debt, but it's a possibility for them now. You think about the guys that started Atlassian. You know, if they built it entirely from day one on cloud technology, maybe they would have been in a different space. Who knows? I mean, they've been very successful as they are, but a lot of their work originally was on traditional compute. Now they run a lot of their stuff in cloud environments. I think it's also important when we look at this to realise that you know, the innovation capabilities that are there means that we should reevaluate when somebody comes to us and says, can we do something in this space? And we could say, well, yes, we can. We can leverage something in a cloud environment to do this for us, rather than maybe having to do it in-house, assuming that the business has an appetite for that. Better hurry up, running out of time. Everyone wants to go for beer. So I think for us to realise the benefit of, to get innovation benefits out of the cloud, we need to move to what I've called a compositional architecture. So rather than building things from the ground up and worrying about OSs and configuring OSs and installing software on OSs and then building stuff on top of that, is we now take a component off the shelf. We use a web app, we use a logic app, we use a service bus, we use B2C, we use the function app. And we start to use composition of these existing technologies to provide us with the underlying capability that our architectures are based upon, rather than having to worry about the software I need to buy to put on the server to deliver the capability. Test and learn these things, and I've been doing a lot of this in the last year with a customer I've been working with. Go out and look at what the new things are that are dropping on a regular basis in a cloud environment. And this applies as much to things like Office 365 as it does to Azure. The biggest challenge for most adoptions of Office 365 is all the new features that keep on coming down the pipeline that change managers' heads just explode over, because end users suddenly get these things and go, oh, what's that? And no one knows about it. And Azure is the same as an IT practitioner, is there's all these new things that keep coming. And invariably there will be some smart developer or some smart IT pro in your organisation that will know more about it than maybe you do, and they'll go, we should be looking at this thing. Testing and learning is a great way to do that. Choose some system that you're going to do a proof of concept on and build it using one of these new technologies. Or build a canary system in one of your production environments that tries some idea using one of these new components. Learn from it. Maybe it doesn't fit in your organisation. Maybe it's not something of value, but maybe it is. Maybe you'll try something and you'll gain an insight into, oh, actually, maybe that would fit over here. The idea that we're now having to commit less capital expenditure up front to provision software, hardware, and other services, and the ability to deliver these things a lot faster, means that we actually have a lower cost to entry to realise new ideas. Now, what that means is that businesses need to shift to the point where what they're actually thinking is, it's okay to try something and fail. I'll throw $60,000, $100,000 at this. Traditionally, I might have spent $2 or $3 million doing the whole project with the risk associated with it, but instead I'll try something for a fraction of that. And if it fails, that's okay, but as long as I gain an insight from it or a learning, then I've gained some benefit from it. And I'm trying to be innovative. I'm discovering these things, because if you don't discover these things, your competitors sure are, or this next startup that comes sure is. And what this drives is a culture of inquiry and innovation, and you start to see, you know, the big banks in Australia have become very good at doing hackathons and running innovation labs. And I can guarantee you cloud technology like Azure is very much at the core of that. Innovation in Azure. I won't go into these too deeply. You will have seen sessions on these already. The idea, though, that in all of these spaces, you could have traditionally have spun up capability in your organisation to at least try these things and discover something about them would have been very difficult. Blockchain, great, what is it? Oh, well, it requires this infrastructure and I need to dedicate some time for someone to do this. Now I can go into the Azure portal and go, give me an Ethereum blockchain environment. Might do nothing with it, but I've created one and I now understand a bit about what that consists of. You know, I've got worker nodes and mining nodes and all those sorts of things. I'm not a blockchain person clearly, but I now have the ability to go and explore that. Big data and storage analytics, already talked about that. You now have the ability to push a button to get access to that. Containers, bringing the deployment, unit of deployment up from virtual machines to containers. We now have the ability to go and try those things. We don't need to put Windows Server 2016 and Windows containers in to try that. We can go and do it in Azure today. Internet of Things, we can try Internet of Things ideas. We don't need to have, you know, public interfaces on our private networking somewhere to make that a reality. We can go and try that. We can go and buy some devices. We can see how it fits into our business. And then gaming solutions. Now, I did have a video I was going to play for gaming solutions, but given where we're at time-wise, I might skip it. If you want to see it afterwards, I can show it to you. But it's about a minute and a half video of a small games company in the States that used Service Fabric to deliver a massively multiplayer online game of like 50,000 concurrent users. It's quite phenomenal. And again, that's an innovative solution. They're a small business. They never would have been able to stand that capacity up to compete with the likes of Blizzard or Ubisoft or one of those guys. Okay, so that's a video. We'll skip that. Very quickly, one of the things I've been doing with my current customer was something like this to do some test and learning on mobile applications. We used automatic deployment to a thing called Hockey App, which Microsoft acquired, which does mobile testing and analytics. We used functions and Service Bus to do a lot of back-end stuff. Pretty much this architecture, not quite the same. We did six weeks of testing and learning in the market, and when we were done, you know what we did with it all? Yeah. Deleted it. All we kept was this down here. And what that was the actual data output from our testing and learning. So we could go back and analyse it at a later point in time if we did. The necessary people wrote their insights and gained the metrics, and we understood how consumers did or didn't use the solution. It cost us, a few $100s to run that for 6 weeks. It probably cost us more time and energy doing all the interviewing with people than it did to actually run the technical solution. We couldn't have done that in a traditional world. It would have been very hard to do that. We probably could have done it, but it would have been more difficult. I'm going to round out this section, and I think this is something I'm pushing very hard, is a thing called cattle architecture. So we have cattle infrastructure, stop having pets, treat them like cattle, stop feeding them, giving them names. Same for architecture, and it sort of harks back to that previous item around, stop holding on to things so deeply because you spend a long time arriving at them. If we move to a component architecture and we use off-the-shelf things to build our solutions, we no longer need to worry so much about the pretty diagrams and the appropriate people approving of these things, because you know what, if something doesn't work, we can change it easily enough. We're no longer locked into having bought all that expensive software and all that expensive hardware. We can change. Now that's a very big shift, and I'm not suggesting that works for every sort of architecture that's out there. There'll be plenty of enterprise architects and people who've done TOGAF and all of that will probably want to lynch me, but the reality is that I think we need to start to align architecture with the way we're doing infrastructure and software delivery now in this space and move faster. Last one, service quality. So service quality has two parts. I've talked about this a little bit before. Because we've got improved efficiency in delivering our services, and we've got lower costs when we actually operate these things, or we've spent less money up front actually getting to the point where we're operating something, we can realise boost margins on the services that we're delivering. Now, that might be in the case where you're maybe charging for a service, but it could be increased efficiency through time to delivery to the end users in your organisation. And as a result of that, we can hopefully turn around some of the realised gains back into a virtuous circle to actually improve the quality of the solutions that we're delivering as we go forward, because we can spend more time doing that rather than all that busy work that we did traditionally. And then we can use cloud platform design and scale to actually provide us with better quality options. Now, again, we have to design for that, and we have to allow for the differences between traditional and cloud-based resiliency, but we can deliver that. So we can do highly available SharePoint farms where they have highly available front-end, mid-tier, back-end DCs. We could put multiples of these in different data centers if we want to do, and then we'd have to figure out how we keep the data in sync, but we could do that for a DR scenario if we wanted to. 38 regions. Who here's got 38 regions they can deploy to in their own business? Who's got? Hey, yeah, okay, these guys use Azure. But that sort of scale is, if you want to try something even in North America, or you want to expand into Europe, sure, you might have to deal with, well, do I care about keeping the data in sync between all of the locations? Maybe I don't, but I now have that option. Again, backup. Azure Site Recovery. I can fail over an on-prem environment, this case SharePoint farm again. I don't know, people love SharePoint farms, there we go. I can fail over a SharePoint farm and a web front end based on Linux over to something running in Azure using Azure Site Recovery. I can plug Site Recovery in at the hypervisor level on-prem. So I'm not caring about agents on VMs anymore, I'm actually right down in the weeds managing that transition. I think Stefan would be a good person to talk to more about that if you want to know a lot more about ASR and backup and those sorts of things. This is from a man called W. Edward Deming. And he was a man from the US that went to Japan after the Second World War and did a lot with Japanese industry to help boost quality in their factories. So when we look at businesses like Toyota and the idea of Kaizen, the continuous improvement, that comes from Deming. If you do any form of sort of Scrum or Agile training, his name will quite often come up as well, because it's really that idea that as a group, you can identify ways to improve and do things better. And this is a quote from him. Improve quality, you automatically improve productivity. And it makes sense. Think about the amount of time you waste investigating issues or fixing problems. Now, if you reduce the amount of those sorts of things you had to deal with, think of the time that you have to do other things. And that's really what I wanted to call out here, is that if you can help improve the underlying quality of what you're delivering, you can spend time doing more productive work. That's really the underlying theme of this, right? Being more productive by not doing things that we really don't need to do. Almost there. So how does all of this have positive impact on risk? So I already talked about the shorter delivery timeframes. We've got reduced costs up front. So we no longer have that financial risk attached to the initiatives that we're undertaking. The pay-per-use, our operational risk, also goes down as well, because we're now no longer worried about having over-provisioned capacity. We can change things at runtime to use different components if the ones we chose when we designed this thing don't work as we expect them to. Compositional architecture is exactly that. Maybe I have the right architecture, I have the right components, but they can't meet the scale. What do? Well, I stamp out another version of that, and then I figure out how I route the traffic appropriately. Maybe I put all of my my Western Australian and South Australian and Northern Territory users onto an instance running in Australia Southeast. And I put all my Victoria, Queensland and New South Wales and Tasmania, not forgetting Tasmania, onto an instance running in Australia East. Okay, and sure, maybe I then need to figure out how I keep the data in sync between those two, but I at least have that capability. I couldn't have done that in the past. I was stuck. I put the hardware into a data center and I was like, well, I have no other options anymore. So a lot of that risk just falls away. So we're back where we started. Thank you very much for coming along today. Hopefully I'm not the man at the wedding for you now. I appreciate your time. My name's Simon Waite. Thank you very much.